Good morning, everyone. Today I'm going to be talking about what's new in Accumulo 2 and the upcoming release of Accumulo 2. If you're interested in playing around with the Accumulo 2, there was an alpha release last night that I think finally went through. We just voted on. There's a lot that's gone into Accumulo 2. Now, the last release with new features was Accumulo 1.8.0, and that was in September 2016. There was Accumulo 1.9.0, but that was kind of a technicality why it was 1.9.0. It's a bit complicated, but Commons Config 1 was in the Accumulo API, and that was causing problems because Hadoop 3 had shifted to Commons Config 2, and we needed to deprecate everything in the API that had to do with Commons Config 1 so we could whack it in Accumulo 2. And since Accumulo follows Symver, to deprecate something, we had to bump Accumulo to 1.9.0. But Accumulo 1.9.0 really should have been Accumulo 1.8.2. It didn't really have any major new features. So what I'm looking at, or when I was looking at this, I was like, what activity has there been since Accumulo 1.8.0 was released? And there's been a good bit of activity, 1,200 commits, if I counted it correctly, using my Git Kung Fu, and 45 contributors. And I did dedupe that, because when I got the unique list of authors, like some people had 4 different email addresses and things like that. So I'm like, okay, take those out. And now I'm not going to cover everything in this talk that's in 2.0. Hopefully the release notes will have a comprehensive list, and we've got those pretty far along for Accumulo 2.0. They're on the website right now, actually. And if I miss anything, let me know at the end of the talk. If there's something you thought that I should have covered in 2.0, just kind of keep it in the back of your head, and we can discuss it at the end. So there were a lot of dependency updates for Accumulo 2. The two that most people are probably going to care about is Java and Hadoop. So those are minimum. So minimum Java 8, minimum Hadoop 3. The first thing I want to discuss are some of the API changes. So what I'm showing here, this is the current Java code that you have to write to connect to Accumulo. And it's not very intuitive, and it's not very nice to look at. The code's the way it is because it kind of evolved in a strange way over a long period of time. But in addition to not being intuitive and nice to look at, it also has some drawbacks. For Accumulo 2, we wanted to be able to put everything you need to connect to Accumulo in a config file. And then you could just give that config file to the Accumulo API and say, give me a connector. Let me talk to Accumulo. But one thing that's baked into the API is you can pass it a config file, but then you create this Zookeeper instance and you have to give that credentials. And we could have made that method like that, where it says instance.getConnector, just take no arguments, and then you could have passed it to the config file, but it was still not a very nice API. So in Accumulo 2, there's a completely new entry point to the Accumulo client that's actually intuitive and pleasant to look at and offers more functionality. So this is what exists in 2.0. You can write new code that says Accumulo.new client, and it's a fluent kind of builder pattern, so you could do a lot of stuff instead of just saying using properties. But the basic thing you can do is just give it a properties file and then build a client. Now, Accumulo client is analogous to the existing connector. It has all of the methods that were in connector in 1.9.0 that weren't deprecated. So it's kind of a source drop-in replacement. This is what the client properties file looks like. So you pass in the zookeepers, your authentication information. And something else you can do with this new API is you can pass in configuration for a client, for client-side tools like the batch writer and the batch scanner. You'll notice like that at the end of the properties file it says batch writer.max write threads equals 2. And if I go back, so in the new client code, when it said create batch writer, it just passed the table name. In the old API, you always had to pass this batch writer config. If you look at the last line where it says create batch writer, you pass the table name and the batch writer config where you don't set anything. So in the new API, you can pass configuration through the config file, and you can also not pass this. You're not forced to always pass this configuration if you don't need to. Now, for compatibility with existing code, connector is still there in Accumulo 2. It's just deprecated. And connector has a static method called from on it, and you can pass from an Accumulo client, and it'll give you a connector. So you can start writing new code that uses Accumulo client, and then for existing code that uses connector, you can easily convert the client to a connector and pass that to the existing code. This is another interesting API change. So what we're looking at here in this example, I want to call out, the really important thing is at the top is that the row and the family are of different types. So the row is a string and the family is a byte array. Now, if you wanted to take this information and build a key, in the old API, key has all of these overloaded constructors. And every one of the constructors has a whole list of fields for the key, and they all have to be the same type. So there's one key constructor that has a list of strings. There's one key constructor that has a list of byte arrays. But when you have fields of different types like this, you have to convert them all to the same type. So you'll see that for K1, that's using the old API, when it creates the key, it converts the row and the qualifier to byte arrays. And then it creates the key. So in Accumulo 2, there's this new key builder. And one of the main advantages of the key builder over the existing constructors is it makes it super easy to mix types. So you can just pass your row and your family and your qualifier. They can all be different types. And it's a nice Fluent API, and you can build the key much more easily. Mutation has something similar, but we looked into creating a builder for mutation. It didn't quite work because mutation is already kind of a builder. So a mutation is a row with a list of column values. And the existing mutation code has all these put methods to add additional column values to a mutation. So what's new, and so these M1 and M2, you're constructing a mutation with the same data. M2 is using a new API, which is this at method. So it's a Fluent API where you can add a column value and you can mix types. So at is kind of, it was something that was discussed on the issue for this, and we were looking for a name that was short and that kind of made sense when you read it as English as a starting point for this Fluent method, and I kind of like it. The at it's kind of like a positional thing, like at this column, put this value. So I don't show these API changes, but what the Java APIs look like, but these were 4 things that were added to table creation. And the first one is really nice. So if you consider the use case in 1.9 of, I want to create a table and then I want to add 1,000 split points to it. So what you have to do in 1.9 is you create the table, and conceptually what's going to happen is Accumulo is going to create a table with one tablet, and it's going to bring that one tablet online. And then as a user, you go back to the API and you say, here's 1,000 splits to add to the table. And what Accumulo is going to do is it's going to go to that one tablet and say, hey, can you split? And then that tablet's going to split into two. And then it's going to go to those two tablets and say, hey, can you split? And those are going to split in two. And it's going to keep doing that till you get up to the 1,000 tablets. So the client code will be driving that split process. And while that's happening, the master will be trying to balance those new tablets, and they'll kind of be fighting with each other, and it'll basically take a little while. But with this new operation, the splits are actually passed to the master at table creation time. And the master just writes the splits right to the metadata table before the table is ever brought online. So, and I have an example later where I show some timing for this. And these other three, the create a table offline, I think that's going to be useful going forward. Right now, there's actually something else I'm going to talk about later. We added some new bulk import APIs, and they behave differently, but they support bulk import into an offline table. So I think going forward, we'll be able to do more things like this, where you can create a table offline and then make mutations to the table, get it just how you want it, and then bring it online. And specifying iterators at table creation time, that's also a nice thing that can avoid certain race conditions, where I create a table. In the old API, you create a table, and then you could turn around and add some iterators. Well, maybe that you don't want users interacting with the table before those iterators are set on it. So there could be a slight race condition there, where it's like you create the table, and then before you can add the iterators, the type of things that happens in distributed systems, some process comes along and adds some data to the table, and some other process comes along and reads data from the table, and you don't want any of that to happen before the iterators are there. So this operation will set the iterators before any of the tablets in the table come online. So since Accumulo follows sim version, going to 2.0 allowed us to drop things that were deprecated in a previous release. So mock Accumulo has been deprecated, for quite a while. That was dropped. Mock Accumulo was nice in that it was fast, but it also didn't implement the full functionality of Accumulo, and some of its methods behave differently. So it was kind of hard to recommend people use it. It's like, well, it's great because it's fast, but it may not be correct. So use it at your own risk. Some of the other things that were dropped were methods in Accumulo that public API methods that use non-public API types. And those methods were never. We weren't doing anything to make sure those methods were stable, because when we analyze, did the public API change? We're only looking at public API types. So if a public API method took a non-public API type, we're not doing any analysis on that type to make sure it's stable. So what that means is that there's no guarantee that that method is stable. So we had created a tool to automatically find methods like that for 1.7, and we found them and deprecated them for 1.7.0, and they were just dropped. Aggregators were removed. If anyone is still using those, they're very self-contained, and it would be very easy to take that code and create a jar. Those have been deprecated since 1.4. They were replaced by combiners. If anyone is still using them and they need help doing that, please reach out to the dev list. And there's other deprecated code that was removed. I want to try to get all of that covered in the release notes. But not everything that was deprecated before 2.0 was removed. So there's been a huge improvement to the Accumulo scripts. So I have two screenshots here. One is doing LS on Accumulo 1.9, and the other one is doing LS on Accumulo 2.0 snapshot. So Accumulo 1.9, we had a lot of scripts, and I don't know if all of them were documented or maintained, and some of them probably shouldn't even have been there. It was kind of a mess. It's what's what's there now is very pleasant. You have these 4 scripts, and each one kind of has a lot of subcommands. So in the example, you can see that, I did ls, and there's an accumulo cluster, accumulo service, accumulo util script. And then I just ran the accumulo cluster script, and you can see that it has all of these subcommands. Like you could run accumulo cluster restart, and that'll restart the cluster. And I guess that would have been, I don't know if there was an analog to restart, but like accumulo cluster start would have been analogous to the start all script. So this is much nicer. It could cause compatibility problems for any automation that's relying on the scripts. So that's kind of the type of thing that needs to be done in a 2.0 release. So one of the big features I'm going to talk about is bulk import changes. If you're not familiar with bulk import, it's a process for Accumulo. It's a way of getting a lot of data into Accumulo. And the way it works is you can use something like MapReduce or Spark to create a lot of files that are sorted key value files for Accumulo. And then you can go to the Accumulo API and say, here's a directory full of files, add it to this table. Now the way this works, the actual implementation, is Accumulo has to take all of those files and inspect them. So it has to go to each file and say, oh, what data do you have in you? And let me look at the metadata for the table you're trying to import to and try to figure out which tablets you go to in that table. And let me load you onto those tablets. And then when it loads onto the tablets, it has to do this transactionally and try to make sure the file's not loaded twice to the tablet, that if the table is splitting while the bulk import is happening, that things aren't lost. So it has to do the inspection, and then it tries to handle the insanity of a distributed system and get those files in there. So what I'm going to go over is how the old bulk import works. Now the changes that were made for 2.0 is a new API was added for bulk import. The new API has a new behavior. But the existing APIs just have this old behavior. So your existing code should work the way it used to. So what happens with the old code is the client starts off. So the client will ask the master, hey, can you load this directory full of files into a table? Now the master's like, okay, I have to inspect all of these files and figure out where they go. And it's like, I don't want to do that here because it could take a lot of memory or network. So the master doesn't want to do it itself. So what the master does is it goes and asks random tablet servers to inspect the files and figure out which tablets they should go to. And to do this, to get somewhat good throughput, it will create a thread pool for the bulk import request. And what the thread pool does is it sends out a remote procedure call to a random tablet server, says, hey, random tablet server, inspect this file. The tablet server gets that request, it inspects the file, and then it sends out a remote procedure call to a tablet saying, hey, can you load this file? The tablet gets that request, and it's going to send out a remote procedure call to the metadata table to add that, oh, my tablet, record that I have this file. And I'm not actually showing all the remote procedure calls that happen here. The random tablet servers, when they inspect the files, they'll be making remote procedure calls to the name node and also the metadata table. So there's a lot of remote procedure calls going on here, and they're all synchronous. So the new bulk import works in a completely different way. The client will do this is one way it can work. It can actually work in multiple ways. The client will do the examination of the files. Now, one thing that's very different, when the client's doing the examination versus all these random tablet servers, the client can actually make a lot less calls to the name node, because it can make a few calls to the name node and get some batches of information, and then just use that. It can also make less calls to the metadata table than these random tablet servers, possibly. Because the random tablet servers may not be able, because they can't basically share information about metadata table and name, information they got from the metadata table and the name node. So the client examines the files. It figures out where the mapping of files to tablets. Once it's determined that mapping, it sends it to the master. Now the master gets that information and it no longer has to do the examination. As a result, it has all the information it needs up front. So instead of making all these synchronous remote procedure calls, it makes a lot of asynchronous remote procedure calls to ask tablets to load files. So if it had to load 1,000 files, it's basically to 100 tablets, it's going to blast out 100 asynchronous remote procedure calls. And it's not going to wait for any of them to finish. So it's going to queue up all this work on all the tablet servers to get the loads going. And then it's going to come back and check on what actually finished and things that, by scanning the metadata table, and things that haven't loaded, it's going to blast out more remote procedure calls, asynchronous remote procedure calls. Now, bulk import to an offline table, that's something I mentioned before. When you do that, you don't even have to send the load messages to tablets. So the client computes the mapping of files to tablets, and then it asks the master to load that. The master's like, the table's offline. It's like, I'll just write those files directly to the metadata table and be done with it. Now this new API, the client can compute the mapping, or you can just pass the mapping of files to tablets directly to the client. Now this gives you some rope to hang yourself, because if you say, oh, this tablet should go to this row range, and it has no data for that row range, it's going to get loaded there. But usually, it's hard to think of a situation where you don't know this. When you're doing bulk load and you're writing a MapReduce job to create your data, the MapReduce jobs, they kind of know where the files should go. So if you record this information somehow and then just call the Accumulo API, you can avoid more trips to the name node and more trips to the metadata table and just say, load this data. Now the code does do some checks. If you ask it to load things to splits that don't exist in the metadata table, it'll get unhappy. So it does have some sanity checks, but it doesn't do any checking to make sure files go where they should. So I ran a little experiment timing loading 10,000 files, create a table with 1,000 splits and then load 10,000 files into it. And I tried to do this in 192, and I also tried to do it in Accumulo 2 with using different API options. So one thing you'll see is that in 192, it took 4.8 seconds to create the table and then add the 1,000 splits. In 2.0, since you can add the splits at table creation time, that was much faster. It took 0.3 seconds. Now the bulk imports, I kind of have this grid, offline and plan. So offline is whether or not the table was offline. So when offline is yes, it means I created the table offline. When load plan is yes, that means instead of Accumulo inspecting the files to see where they went, it just said, send this file here. And the way I did that in this particular example is I was generating random data. For each file, I would pick a random tablet and generate data within that row range. And in the file name, I actually just put the first and last row of the tablet. So when I went to do the bulk import, I could just look at the file names and see where they went. But basically, you can see that the fastest bulk import was 3.1 seconds, and that's when the table was offline. So it created an offline table with 1,000 splits. And then I gave the bulk import operation a load plan that says exactly where the files should go. And that was 15 times faster than 192, which took 47 seconds for that same operation. Mm-hmm.
So, does 2.0 include a new balancer so that the tablets are distributed right away?
I don't know if we've changed the default balancer. I mean, balancers are pluggable. So, yeah, but if you create a table with splits and then just bring it online, I think it should just evenly balance those immediately. But I haven't actually experimented with that. That'd be a good thing to try for Tua, because I don't see why that shouldn't happen. If it doesn't, I'd consider it a bug. One of the things we want to do with the alpha release is do a lot of testing, so that would be a good test to do. So summarizers were another interesting thing that was added for 2.0. So these allow you to add user-defined functions to tables that continually generate summaries of what's in the table. They're kind of similar to counters in MapReduce, and they also share, they're also similar to combiners in MapReduce and how they're implemented. So this is an example of a table that was configured with a summarizer. It's a summarizer that attempts to count the unique column visibilities in the table. So there's a scan in the shell that shows what data is in the table. And the column visibilities are the things like PI and geo, or PI and time. So after the scan, you can see that the summaries command is run. And the summaries show that the table has a visibility summarizer configured. And the visibility summarizer has counted that there were 4 columns with no column visibility, 1 column with one entry with column visibility of PI, 2 entries with column visibility of PI and geo, and 3 entries of column visibility, PI, and time. Now, the way this particular summarizer works is it will only count up to a certain number of unique column visibilities. So, and that's configurable, but I think by default it tracks up to like 5,000. And the reason for that is the summaries should ideally be small. So, and what it'll do is if you go over that unique number, it just counts how many were uncategorized. So it just keeps account of that. So from a user standpoint, using summarizers, you can configure multiple per table. So you could configure that visibility summarizer. You could also configure Accumulo has a built-in delete summarizer that counts how many deletes are in a table. And you can configure multiple per table. And the way it works is if you had an existing table and summarizers were never configured on it, and then you configure them, as new data is written and files are compacted, those new files will have summary data. The existing files will not have summary data. And going back to the example, there's a line there that says file statistics. And what that tells you is when you go request summary data, it tells you how many files contain that summary data and how many files did not have the summary data. So in this use case where you had a table and you've added summarizers to it, but not all the data is summarized, you can get a sense of what's missing. Or you can know if everything has summary data or if some of the data hasn't been summarized. And there's 2 ways to consume the summary data right now. There's a client API where you can give a row range to a table, and it will just grab the summary data in that row range. The second way is that user-written compaction strategies can access the summary data and make decisions about which files to compact. So some use cases for this would be like, oh, every once in a while I have to filter out some data that may be rare. If you had summarizers that characterize that, and you could see that, oh, only 1% of my files actually had this data, and your summarizers were able to characterize that, then the compaction could only compact the 1% of files that have the data based on that. Another use case would be like, I want to compact files that have a certain percentage of delete entries. So the way Accumulo deletes data is it inserts delete markers, but the data is still there. And eventually it goes away when you do a full compaction of the tablet. But until that happens, when you scan, scans have to look at those delete markers and just skip over them. If you had a tablet that was 25% deletes, it could really slow down scans. The summarizers provide a nice way to deal with this. So you configure a table with this summarizer that just counts deletes, and then you can configure a compaction strategy that looks at that and says, oh, when a tablet is over 10% deletes, 30% deletes, do a full compaction on it to get rid of those. For implementation, summaries are stored in each R file. For efficiency, there's a cache of summary data. And the main purpose of this is like, if compaction strategies are repeatedly going to be asking for summary data to make their decisions about compacting tablets, you don't want them to have to go to the R files, go to HDFS to get that information. So hopefully you're creating small summaries and that easily fits in a cache, and the compactions can grab that. The compaction strategies can grab that from the cache and quickly make decisions about what to do. Oh. And since summary data may expose sensitive information, there's a new table permission. When you do that client call to get summary data, you have to have the table permission that lets you read summary data. And that's a separate permission from just being able to read the table. This is an example summarizer. It shows the delete summarizer that I was talking about that counts deletes in a table. And summarizers have two parts. The first part is a collector, and the collector is what sees all the data that's written to an R file. And the way it works is there's two methods. There's the accept method that just gets every key value that's written to the file. And then there's this summarize method that's called periodically. And the summarize method should just emit string long pairs. The way this is structured, the summarizers can be really efficient. Because like in this example, for every key value, it's incrementing a long, checking a Boolean, and possibly incrementing another long. So it's not doing much work for each key value. And then the summarize function is just called periodically. So there's the collector, and then the other part is a combiner. And the combiner, its job is to combine the output of the collectors. So the collectors, conceptually, they output a map of string to long. The combiner's job is to take two of those maps and combine them. And what that Java 8 Lambda code is doing in the combiner is just summing two maps, the values of two maps, merging them. When they have the same key, sums them. This just shows how summaries are stored in an R file, and the fact that an R file can have multiple summaries in it. And also the summaries they're not for the whole R file, they're for row ranges. So each R file can have multiple summaries, and then each summary can cover multiple row ranges. And the way that works is as the data is being written to an R file, it'll take the first like 1,000 key values, summarize them. And then it'll take the next 1,000 key values, summarize them. And it remembers the last row for that summary. And it does that up to like 10. And then once it gets to 10, it'll combine those 10 summaries down to 5. And then it'll start summarizing every 2,000 key values. And then it'll start summarizing every 4,000. So that's kind of how it builds this in a one-pass, with a one-pass algorithm, but you still get granular summaries. And that's useful for when you go to a tablet and ask, oh, give me summaries for this range, where the range may be smaller than the tablet. And this just shows how the clients gather summaries. So they go to each tablet, they ask for the summaries, and it combines the summaries for all the R files in that tablet. And then it combines the summaries from all the tablets on the tablet server. And then the client gets the output from all the tablet servers and combines those. Let's see, how do I do? So this is a bit complicated to describe. Let me try to do this simply as possible. And so I was talking about in 1.7.0, we found API methods that use non-API types, and then we wrote a tool for that. So in Accumulo, we have all these plugins, like the balancer and things like that. And as we add these plugins, we just kind of sprinkle them in random places in the Accumulo code without much rhyme or reason. And the plugin types, some of them have good interfaces in that they don't use a lot of internal types. And some of the plugins, their interfaces are not good. They use a lot of internal types that nobody's checking to make sure that they're stable over time. So for 2.0, a new SPI package was created in core. I think it's like Accumulo, Org Apache, Accumulo Core SPI. And within that package, we run something called Appleizer, which is a plugin that came out of the Accumulo project that checks to make sure that an API only uses the types you expect. So basically what we have in 2.0 is new plugins go in this API package, and then we check. So we run these checks in the Accumulo build. Do API types only use API types? And we have this new check, do SPI types only use SPI or API types? And what we're looking for is we want to make sure they don't use implementation types. And in 2.0 we have 3 new plugins that we've added. We've added a new crypto plugin, which there will be a talk about today, a new caching plugin, which I don't think anyone's going to talk about. And for this new caching plugin, there's a little kind of prototype cache that uses an off-heap cache from Cassandra that allows you to avoid the Java garbage collector for really large caches. And I did an experiment with that, and I was able to put like 1 billion key values pairs in a 40 gig cache and then just do lots of random lookups against it. It was pretty neat. And another new SPI, or plugin that was added for Accumulo, is scan executors, which I'll talk about briefly. So we could run into this problem with Accumulo where long-running scans can cause problems for short scans. And the reason for this is that scans are processed by one thread pool or executor in the tablet server. And that thread pool just has a FIFO queue. It doesn't have anything to prioritize it. So in Accumulo 2.0, you can create multiple executors. And for each executor, you can provide, a user can write a prioritizer. And that's one of these new SPIs. And you can also, the user can also write a table dispatcher. And the table dispatcher, what it does is when a scan comes in, it has the option to say which executor should process that scan. And the third part of this is execution hints. And that's something the scanner can pass that the dispatcher and the prioritizer can see. So for example, an execution hint could be like, oh, can you give me executor foo? Or, oh, can you set the priority to 5? Execution hints they don't have to be honored by the dispatcher or prioritizer, but they're visible to them. And in this example, there's 3 scanners. The 2 scanners on table Y, one of them ends up being processed by executor A, possibly because of execution hints it's sent. And the other scanner for table Y gets processed by executor B. I did a quick performance test using this new scan executor service. So I created a small table with 1 million key values, single tablet server, and then I had 50 threads continually doing table scans against this table. And then I had 5 threads that were trying to do random lookups with all this mayhem going on with the 50 threads. And I tried doing this experiment with and without prioritizers. So in one run, I had a prioritizer that would honor execution hints with a priority. And it would just look at the priority, and if the priority was like 1, it would go first in the queue. So I had the 50 threads pass a priority of 2, and I had the 5 threads doing small random lookups pass a priority of 1. So with the prioritizer, the 5 threads doing random lookups, their average lookup time was like 4 milliseconds. Without the prioritizer, their average lookup time was 118 milliseconds. There's a lot of other improvements. I'm not going to cover them all. I'll go over some that are interesting. So Accumulo was modified to work well with Docker. And one thing that's kind of nice about this is the changes that were made for this probably will make Accumulo work well in any other downstream environment. Because the key to making Accumulo work well in Docker was to make less assumptions about your downstream environment and the upstream environment. So one example of that is Accumulo. The Accumulo tarball that we build, it tries to do a lot for logging, and it does too much. So in Docker, you just want to log to standard out. Another nice thing about the changes for Docker is you can pass configuration to Accumulo on the command line. So you can pass everything you need to connect to Accumulo with these -O options. So this example shows like running the master and passing all the instance things that would normally be in your config file. So there's no config file, you just pass everything you need, and then Accumulo gets what it needs from Zookeeper and logs to standard out. This was a new compaction strategy that was added that allows you to compact small files with something like Snappy that's fast and large files with gzip. So it gives you better throughput without wasting space, because Snappy is going to be much faster and your small files are probably short-lived. That's the assumption it's making. The Accumulo monitor was updated, and it was updated to be a REST service, and then you have JavaScript calling the REST service. And it looks a lot nicer. I have a screenshot of the old monitor and the new 2.0 monitor. But in addition to looking nicer and being newer technology, it's also a lot less code and much more maintainable. Accumulo had examples built into them. Those were moved out to their own repository. It's really nice because the examples when they were built into Accumulo, it was always really hard to actually modify and run them as a user, because you had to build Accumulo itself to build the examples. Now that they're in their own repository, you can build the examples by themselves, and you can build them against a released version of Accumulo. So there's been a lot of internal improvements for 2.0 that are hard to, some of them can be hard to talk about, but Accumulo, unfortunately, has a lot of static types, and that needs to all go away. Like, we shouldn't be using global variables. And they're still there, but there's a lot less, or there's less in 2.0. So a lot of work was done to take things that were being accessed from static types and move them to these two internal types called client context and server context. And those are just passed around to all the to server and client code, and they have what you need hanging off of them, rather than going and getting something out of a random static type, and you may have race conditions and all kinds of weird stuff. Let's see. These are some other internal improvements. I'll go over these really quickly. ImpSort was actually a plugin that was developed just as part of working on Accumulo. So for the longest time, Accumulo has used Maven plugins that format the source code. But for whatever reason, those plugins do not do anything with your imports. So if two users are sorting their imports differently, it doesn't do anything about that. So this little plugin will sort your imports. Anybody could use it. It's great. So it basically gives us the full functionality of what the IDE would do in the build. So any user can use whatever they want, do whatever they want. When you run the build, it's going to format the source code and sort the imports in a consistent way, and that's great for avoiding unnecessary merge conflicts and Git and things like that. Internally, Accumulo used string for table IDs, and it could be very confusing because a lot of times in the internal code you would have something like string table being passed to a function. You never quite knew if that was a table name or a table ID. Sometimes the variable name would be like string table ID or string table name, but not all the time. So this internal update was made to create a type for table ID and use that internally. It's great for correctness and maintainability of the code, but you'll never see that on the outside. Accumulo has had its own custom class loader that was complicated and hard to understand, and that was deprecated. It's still there. We moved the functionality of constructing the class path into bash scripts, and in a very standard way, you set the class path for Java. So this is actually much easier for anyone who's not familiar with Accumulo, but they're familiar with Java, to come in and understand, rather than our custom class loader. And hopefully we can eventually get rid of that custom class loader because it is very hard to maintain. And there were iterator stack performance improvements in 2.0. And you can, this is kind of neat, you can configure memory using percentages. So there are certain things like a cache size you may configure in Accumulo, and you used to have to say like 500 meg or 1 gig. Now you can say like 30%, and it'll look at how much memory the machine has, and it'll set that to, if you have 1 gig, it'll set it to 30% of 1 gig. We moved to GitHub issues from Jira, and these are some things that I might like to see in the future. I don't know if they're a good idea or not. I think Accumulo is really tightly coupled to Hadoop, and I don't know if that's really necessary. Personally, I don't know if this would ever happen, but I think it would be nice to be less tightly coupled to Hadoop, because what is Hadoop? As far as I can tell, Hadoop is HDFS, MapReduce, and Yarn. What does Accumulo need from Hadoop? HDFS. We need HDFS. And so we could possibly decouple the Accumulo code base, kind of move all our Hadoop code to one spot, one module, kind of have a DFS SPI for Accumulo. So we could take that further and say, let's modularize the code and have a DFS SPI, write-ahead log SPI, cluster coordination SPI. I don't know if this is a good idea or not. It's just something I've been thinking about. And then possibly you could plug in different DFS implementations, instead of always using Zookeeper, maybe use etcd, plug in different tracing implementations. This one I'm going to go over really quickly. So if you write asynchronous code, you can get throughput. And I did this for Fluo, and I got much better throughput. And it's interesting trying to understand why. So when you have a tablet server and you're throwing mutations at it, right now you have, every time a client comes and throws a batch of mutations at a tablet server, there's a thread that shepherds those mutations through. So they have to go through all these steps. And what you want, ideally, to get good throughput, is you want the tablet server to have a lot of mutations there at the ready to go through these steps. So ideally, if you would say, I want to buffer up to 1 gigabyte working set of mutations in tablet server's memory so it can always keep things busy. Because getting good throughput is about keeping things busy. But what happens in the per-threaded model is you don't have direct control over the amount of memory that's used for buffering, because your knob is adjusting the number of threads. So say, oh, I'm going to set it to 500 threads. Well, you may blow memory out because it's indirect. You're not getting it directly what you want. When you move to an asynchronous model, you don't have a thread shepherding mutations anymore. Each step for writing mutations has probably its own executor service and its own queue. And you keep throwing the batches of mutations on these different queues. And what you can do is you can limit the amount of mutations that come into the whole system. And then they kind of get walked through. So I don't know if I ever get around to this, but I think it could dramatically increase throughput for read and write if the internal code was designed to be asynchronous. Maybe that won't be necessary. There is something called Java Project Loom, which would give you something like Go. I think they're called Go routines in Go. And Go routines in Go, they try to make writing code that gives you the benefits of asynchronous code, but you almost write it in a synchronous way. But you can get the nice benefits that you get from asynchronous code. This is something I'd hoped to do for 2.0, but I didn't get to it. I would like to do something similar to what I did with the scan executors for compactions. And to basically solve this problem that long-running compactions can prevent compactions of new files for tablets. So if I have a tablet with 3 1 gigabyte files, and the tablet's churning away, compacting those 3 1 gigabyte files, and 50 1 megabyte files come in, they can't be compacted until that big compaction finishes. So it'd be nice to be able to allow tablets to have multiple compactions running on disjoint files, to have multiple executors for compactions, and to have prioritizers on those executors, user configurable prioritizers. Some other things that would be nice to see, and I think Mark Parisi is going to possibly talk about this, multi-language support, which we have the proxy, but I don't think that's ideal. I think the best way to get multi-language support is you write your client code in C, you have a C API, and then every language has the ability to efficiently interface with a C API. And it'd be nice to have eventually consistent reads. So basically, the ability to kind of have ghost copies of tablets and allow you to read stale data for efficiency. And that's it. Any questions? No. It's just the startup class path stuff. Yeah, but the per table class path are unaffected. So what we've kind of been discussing in the community is that the alpha is kind of like a feature freeze. And so we just released the alpha. And now we're going to try to test it, review it. And we're not going to add any new features. So it's kind of how fast can we do that, the testing and review. And we would love people to review the new APIs also and the new features, because with the alpha, you know, they can still be changed. We haven't frozen the API. Like the per table class? No, that still works as is. Yeah, but I guess there was this functionality where you could load not per table class path, but Accumulo itself from DFS. And that's still there, but if that deprecated code was removed, that functionality would go away. No. For the summarizers that a user writes, there will only be one thread ever like giving it key values and then asking it to summarize them.
All right. Thank you, Keith.
Mm-hmm.